This week, as part of Game Week for my students, we played songs on weird settings on my other keyboards. This resulted in pieces sounding like Star Wars fights with lasers and lightsabers, pew pew, ping ding ding, all over the room. But do lasers actually make a sound? According to Gizmodo.com, powerful lasers do make sounds, but they're not pew pew, and they don't come from the light itself. Instead, the noise comes from the equipment that generates the laser light or the interaction between a laser beam and an object. So I wonder what sound, if any, the equipment made during this recent laser event. On April 26-27th, a 2-day experiment was run by the Deep Space Exploration Laboratory, DSEL, using the Tiandu 1 satellite, one of 3 spacecraft launched in March 2024 to lay the groundwork for an Earth-Moon communication and navigation network. China's Deep Space Exploration Laboratory, working with Yunnan observatories during a 2-day experiment, achieved something previously thought impossible. A laser was fired from a 1.2-meter telescope equipped with a newly upgraded near-infrared system. It hit the Tiandu 1 satellite 130,000 kilometers from Earth and returned a clean signal despite intense solar background noise. Until now, such experiments could only be performed at night due to sunlight overwhelming the laser return. This first ever feat of measurement was accomplished with a satellite called DRA Tiandu 1, located about 130,000 kilometers away. This was possible due to a special reflector on the satellite and a powerful 1.2 meters telescope on the Earth. The Moon is approximately, on average, 384,400,000 kilometers away from the Earth. Tiandu 1 has an irregular orbit around the Moon. Its distance to the surface varies, but it maintains a steady 200 kilometers separation from its sister satellite Tiandu 2, which is also in Moon orbit. This laser feat from Earth to satellite and the return in daylight hours is comparable to hitting a single human hair 10 kilometers away. So besides this first ever satellite bounce measurement in daylight, why is this a big deal? Satellite laser ranging is the gold standard for pinpointing orbits. Ground stations fire nanosecond pulses, which bounce off retro reflectors on a spacecraft and return to reveal distance down to centimeters. The technique is routine for low Earth satellites, even in daylight, but glaring solar background noise has so far limited Earth to Moon or satellites in a Moon orbit shots to a nighttime window only. Achieving that kind of accuracy in daylight means China can gather orbital data anytime Tiandu 1 passes within view, multiplying the number of usable measurements and improving long baseline positioning. This feat also is a huge factor in cementing China's goal of putting astronauts on the Moon by 2030. What kind of sound that laser made, if any, is up to anyone's wild imagination. 2 weeks ago, the Fun Fact discussed Vera C. Rubin's work and proof of dark matter existing within galaxies. But back in 2018, NASA Hubble mission scientists published an article about an oddball galaxy that was lacking in dark matter. This next image is Hubble viewing the ghostly galaxy lacking dark matter. This large, fuzzy-looking galaxy is so diffuse that astronomers call it a see-through galaxy because they can clearly see distant galaxies behind it. The ghostly object is cataloged as NGC 1052-DF2. On April 25th of this year, astronomers stumbled upon another ghostly galaxy that appears to be devoid of dark matter. Discovering a galaxy without dark matter is indeed perplexing, like finding a shadow without a source. Yet over the past decade, several such sightings have been reported, all of them so-called ultra-diffuse galaxies, which are about the size of our own Milky Way but remarkably sparse in stars. The latest member of this puzzling collection, known as FCC 224, resides on the fringes of the Fornax cluster, a collection of galaxies that lies roughly 65 million light-years from Earth. First spotted in 2024. FCC 224 is a dwarf galaxy that boasts a dozen luminous, tightly bound clusters of stars, an unusually rich population for its size, typically seen in larger dark matter-rich galaxies, yet appears to lack the mysterious substance. It also occupies a distinctly different cosmic neighborhood than other galaxies that are deficient in dark matter, suggesting such objects might not be isolated flukes, but rather represent a more common, previously unrecognized class of dwarf galaxies, according to 2 complementary papers published last month. And the best part is, quote, no existing galaxy formation model within our standard cosmological paradigm can currently explain how this galaxy came to be, end quote, states Maria Bozo, a doctoral candidate in astrophysics at the Swinburne University of Technology in Australia, who led one of the new studies. So, astronomers now have yet another galactical mystery to solve. Every day our world has little and sometimes big surprises for us that alter our thinking patterns or take an accepted view of a well-known item and change it, like this absolutely older but adorable Potsdam Gravity Potato. I will never think of planet Earth exactly the same way as before. What is the Potsdam Gravity Potato? The gravity on Earth is not the same all over. In Potsdam, Germany, data from orbiting satellites Grace and Champ were used to create a gravity map of the Earth. Blue areas are low gravity, red areas are high. Scientists do not yet know all the causes for the varying levels of gravity. Why potato? Because scientists have a sense of humor, love naming things, and it looks kind of like a potato.